This is a demonstration video on how to use the Simple Tungsten Etcher. I'll go through two different etches today. The first will be a calibration etch, and the second will be a normal tip etch. So here I have an example of what we're doing. This is the current versus time on a typical etch. And the circuit works by detecting this big drop-off and terminating the etch during this drop. So the first etch will measure what voltage we should set to land somewhere in this steep drop-off. The closer to the top of the drop-off you can set your voltage, so the sharper your tip should be in theory. But we'll get it anywhere within here on the first etch. Sometimes it takes a couple etches to get the cutoff set just right. But for most cases, even in the middle is fine. So that'll be the first etch. The second etch, I will not intervene at all and just let the etch complete normally. And then after this, I will show some images of those tips. Okay. So here's the procedure for doing the calibration etch, the first etch that we're doing. This is linked in the manual. There should be a web link in the description of this video, and that's on my website. So first thing we should do is power on, so you can see the machine's already powered on. It's been sitting here warming up. And so then the next thing you do is set the etching voltage. I'm going to use 10 volts for this etch. Yeah, it's not that important. Actually, I think I'm going to use 12 volts just to make it go a little faster for the demonstration. Yeah, next thing to do is then set the jumpstart overshoot. We're not going to need to do this. This is already set before I ship the machine. However, if you do want to change it, it should be around 1 volt normally. I have the adjustment on there in case there's some strange circumstances why you'd want to change it. But and then the next thing we'll do is make sure we're in the right mode. I'll show you. Well, I can show you now. Make sure the mode switch is in cutoff. That's this switch here. So this switch, there's two different settings. The bottom setting is on, and that just applies a constant voltage to the tip. That's just whatever the etching voltage is just always applied on the tip. But we want to operate in cutoff mode, so we'll leave it in cutoff. The reason why we want to do the calibration in cutoff and rather than just in on is these MOSFETs have some voltage drop associated with them, and we want to make sure that we're taking that into account whenever we do the calibration. Okay, and then we'll set the cutoff voltage close to 0. So let me pull the oscilloscope up here. I'll show you a video of what the setup looks like. But so I'm going to use 2 channels on my oscilloscope. One channel for measuring the etching current. Set these in here. And then the other channel will be just used to visualize where the threshold current is. You really only need one channel to do this, but having 2, I think, is a little bit easier to see what's going on. Okay, so I will. Well, first let's get the etching voltage set. So let me move the camera and okay. So right up here is the oscilloscope graph, and right over here is this USB microscope. Both of those will be there for the rest of the video. So if we go over to the oscilloscope, go to channel 1. Let me speed up the time here so we can actually see the changes in real time. So I'm going to change it to be, let's do 12 volts. That should save some time for the demonstration. Okay, there's 12 volts. And then the cutoff, move this down to the cutoff. It needs to be low. Something around 200 millivolts is fine. Yeah, let's just do 100. It just needs to be low. You'll see why in a little bit here. And then I'm going to move this probe onto the current monitor, which is this pin down here. This pin down here is buffered, and this is the raw readout. You want to make sure you use the buffered. Otherwise, you can affect the measurement itself. And the second trace, the purple trace in the oscilloscope, channel 2, that will be on the cutoff here. which won't really be important on this first etch, but on the second one it will be. Okay, and next you want to load some tungsten. I need to change it. You want to make sure that your tungsten is straight and debris clean, or debris free I should say. It also needs to be quite straight. I like to use a little dental pick to straighten out the wire. If it doesn't go in straight, your tips will come out curved. Not quite curved, but they won't be symmetric, rotationally symmetric, I should say. All right, let me get this on the pad. Okay. And I will fill this with etchant now. You need to rinse the dish with DI water before every etch, and you should replace the etchant every etch. That's a bit overkill, but it's cheap. There's really no reason not to. So let me go do that off screen. For this etch, I'm using 2 molar sodium hydroxide, 2 molar solution. You can use a lower concentration, it will just make the etch take longer. Doesn't really matter that much, just matters that it's consistent. And okay, now this is filled with sodium hydroxide. Put the alligator clip on, and I'll move this camera so you can better see. So now I'll just drive the tip down into the liquid until it touches, and then there's graduated marks on this knob that go in 250 micron increment, and I'll use that to get the submersion depth. We're going to use 1.5 millimeters for this etch. Anywhere from 1 to 2 millimeters is good for this 250 micron tungsten. Okay, there's the surface. So I'll touch it, and then I'll move this 6 times. 1, 2. Okay, so now the etching current is set, the etching voltage is set, the cutoff is set low enough to etch to completion. We're ready to do an etch, but let me just show you the setup first before I start. I want to make a comment. So here's the etching setup. I have it inside this acrylic box, and the reason being is mostly for air currents. Then I also have it on the steel plate for vibration isolation. And then I have the oscilloscope over there. The box is quite useful to keep air currents. If you have a lab where there's really no air currents, you can just do this there. But unfortunately, in my lab, there's a lot of air currents and also lots of vibrations. So that's why I have the vibration isolation and the box. Just about any box would work. Just about any box would work. It also keeps the setup clean. I have the box that I'm using linked below if you're curious, but they're pretty cheap and many would work. Okay, so I'll just press this button to start the etch. And I'll gently close the box, which unfortunately is magnetic. Okay, and let me zoom in a bit and bring the time history to longer. Alright, this will take about 10 minutes to do this etch. Hopefully the meniscus doesn't break during the etch, that happens sometimes. I'll be back when it's done. Okay, looks like the etch terminated. And I'll go ahead and pause this. And let me bring my cursors up. We want cursors in Y. And I'll just measure this voltage. So, whoopsie. We will put the current threshold, just to be safe as a demonstration. If I were running this with multiple etches, so you'd have more time to calibrate it, I'd put it right up here, right close to the top. But for the sake of the demonstration, I'm just going to put it right here at 2 volts. So my cursor's not doing that. So what I'll need to do is come in here, and the cutoff voltage here, that's this knob, I'll resume. So first you should make sure they're on the same scale, and then I'll set the time to be something quite short, and then I'll change the cutoff. I'll bring it up to that cursor mark, which is at 2 volts. So right there, 2 volts. And now I'll just run an etch again, and it should be self-terminating. Here I can show you the tip. Let's see if I can get a good camera view on this. It's going to be a little tricky. Yeah, I don't know if you can tell, but that tip is blunted. It looks over-etched. So you'll see on the next etch the tip will look better. I can show some images of these 2 tips in a little bit. So let me reset up for new etch. I'll change out the etchant, rinse the dish, and load new tungsten, and then I'll be back. I've changed the etchant and loaded new tungsten. And so the etching voltage was set from the previous etch, and we just adjusted the cutoff current, I should say. So now it's just to run it in operation. I will submerge the wire, the same 1.5 millimeter. Okay. And I'll go ahead and start the etch. This will take another 10 minutes, should be about the same time as the last etch, and I'll be back when it's done. So this etch you can visually see is much sharper. I can show images of this later. But you can see over here on the oscilloscope curve, the etch terminated. Well, so the tip snapped off, and then where the purple line is, that's where the current was terminated. So you can see it's visually just way sharper than the calibration etch. Again, I can show images of that in a bit. So let me remove the wire. And after etching, these do have debris on them. They have tungsten oxide and also sodium hydroxide from the etching. And to clean these, I don't have any handy, but I just take them and dip it into a beaker of fuming hydrochloric acid, and that cleans it right up. But if you don't have that, just some deionized water, rinse it in deionized water very gently so you don't bend the tips. But even that is better than nothing. Here's the first tip. This is the one from the calibration etch. You can see that it's quite blunt because it over etched and etched the tip away. Here's a zoomed in picture of that. You can see the tip radius is, I don't know, maybe about 4 microns or so. More than a micron, which is really bad. But after the calibration, we get a much sharper tip. And this is just a desktop scanning electron microscope. And you can see on the zoomed in picture here, I'm not able to resolve the tip. It's really hard to say what exactly it is here, but it's definitely under 100 nanometers for sure. If you have any questions, you can shoot me an email or WhatsApp. My contact info is on my website, bairdlabsllc.com. You'll also find purchasing information and a manual to download if you're interested. Thanks for watching.